room. Ben and I were expecting that might just be the two of us, being at the parties last night, etc. But anyway, welcome. I'm Jesse Sooner. This is Ben Wolf.
Hey.
We're program managers in the Azure Identity Division. Our role, we're in a team called GTP, or Get to Production, but basically this is a type of role that you'll see more and more across Microsoft, which is a reflection of the way that we're now building software and releasing capabilities, features on a really regular basis. And product group needs to have tighter engagement, better interaction with customers to make sure that customers are getting the right information to deploy, but also that we're getting the right information back from customers, so we're building the right features, prioritizing the right capabilities within our stack. So that in mind, our topics today are really focused around some of the Azure Active Directory premium features and how to deploy them, basically. So we really want to enable you guys to go out there and both Azure AD and Azure AD premium features, be able to recognize the opportunities to deploy them in your environment, and we want to share some of our experiences, some of the do's and don'ts of getting these things deployed, getting it right. So, in our role, Ben and I work with a bunch of big customers, but we also work in a team that also works globally with customers all over. So we're able to see, the types of challenges people have, and we're going to share some of that insight with you today. We're going to show you really the lessons that we probably learnt the hard way, with things that are going to slow down deployment, or things that you need to really head off before you get too far down the track of getting these things in place. We're going to talk about some of the key design decisions with selection of capabilities that you're going to deploy, as well as how things work, so you can understand how better to get them into your environment. And then we're really going to try and optimize the session around the things that are really achievable. So really starting to get some value for your investments around our identity capabilities.
Thanks, Jess. Just a quick show of hands. How many in the room are using Azure AD either through Office 365 or through EMS? And what about as a premium SKU? All right, cool. So like Jess touched on, we're going to pretty much concentrate on the premium aspects of the service. But hopefully when you see those the capabilities of what you can do and how easily you can turn those features on, it'll show you the value of perhaps moving up to the paid SKU of Azure AD, because there's effectively the free version of Azure AD, which you can just create and consume and do quite a lot with. And you get what they refer to as basic edition, which is kind of what you get with Office 365. You can do some core capabilities just through that Office 365 license SKU, but normally where you'd have to buy Azure AD Basic separately. And then you've got Azure Active Directory Premium, of which there's two SKUs now, P1 and P2. The P2 SKU contains identity protection, so the ability to take in signals that the authentication platform picks up and apply risk and user-based policies to those sign-ins. So you can block, for example, someone from signing into Office 365 from a Tor browser. You can also do privilege identity management, so that just-in-time elevation to management of Azure AD workloads, and that's going to flow down into Azure Resource Management as well. But they're the kind of additions of Azure AD. And as we go through this, if you guys are using it, first of all, we're happy to take questions as we go through some of this stuff. But if you've got feedback on issues or just anything in general, around your deployment, happy to hear those either afterwards or throughout the session. But this is how we've structured the deck. So kind of the logical progression is you start your first experience with Azure AD from an administrative perspective. So what you would do and how you would approach this. So configuring the tenant, which is fairly straightforward. This is obviously critical, choosing the authentication method you want to use. There's a lot of choices now, where historically it was kind of either you did ADFS or you did password management in the cloud. Now we've actually got some really unique and simplified use cases that essentially negate the need to do ADFS. So probably the theme of today's session around authentication is don't default to ADFS if you're looking at this from the get-go, which seems to be a common theme we see, which can lead to lengthy times consuming and engaging with the service, but also can overcomplicate situations and it becomes a bit of an admin overhead. There's still perfectly valid use cases to use ADFS, but just don't default to it out of the gate. AD Connect, the deployment of that, and also by extension Connect Health, which is a monitoring solution that we have built into the platform now. Enabling self-service password reset, SSPR, with write-back, so the ability for a user to change their password in the cloud but have that effectively written back to the on-premises Active Directory real-time. Conditional access and MFA, these are kind of the really strong selling points of Azure Active Directory Premium. Really granular levels of conditional access that you can now apply to individual workloads gated by Azure AD. So if you want, for example, to prevent any external users outside of your corporate network from, say, logging onto SharePoint online, you can do that with conditional access. Or you could say, allow them to log onto SharePoint online from home, but only from a domain joined machine. Or proof up with MFA before you can access that. App proxy, any of you guys using app proxy in the room? How do you find it? So app proxy is kind of our replacement for what was historically ISA TMG web application proxy, the reverse publishing of an on-premises web service, but basically driven through Azure Active Directory. So no more server needs to be deployed on premises. You just install these lightweight connectors. They talk through to Azure Service Bus, which sits underneath Azure Active Directory. And as a user, I can access an on-prem website where you don't need to open port 443 or 80 like you historically did to make that accessible. I come through and all through Azure AD, and Azure AD on behalf of the user goes and talks to the connector, which talks to the web service and brings back the page to the user. So you can gate the app proxy solution with the conditional access and MFA capabilities on top of that. So it's a really nice, secure way to publish an internal web application securely, but without extra server hardware, physical or virtual, to do so. And then the last one there is turning on identity protection. So identity protection is the P2 SKU, which is the more expensive per user per month SKU. But one of the things you can do is sign up for a free trial. So if you're not on Azure AD Premium today, you can light up Premium and P2 capabilities for a 30-day window and turn this on, and it will give you insight into the risks that are going on with your user authentication. So are users signing in from compromised devices? Are users signing in from accounts that they themselves have been compromised? We actually trawl the dark web and get compromised credentials from, say, Yahoo and things like that we can map back to an Azure AD account. And if you've got password hash sync on, we can actually map that back to a password hash as well, and we can tell you if credentials have been compromised. And identity protection gives you that insight, and then you can apply a workflow to reacting to that. You might want to force the user to reset their password or turn on MFA or disable their account. But you can try this out for free for 30 days just to get insight into that risk, and after 30 days, it'll just stop working. It won't impact your tenant or anything like that, but you'll get access to the reports. So the first step, setting up your tenant. We'll go through some common do's and don'ts, and the don'ts, these are really constructed from real-world experiences and kind of gotchas that you want to avoid or turn on that you might not be aware of that are there. So tenant branding, if you're Office 365 or on Azure AD Basic or higher, you can brand the logon page for Azure AD. So users that authenticate to those cloud-based services get a feel that they're hitting a company-centric portal, even though it's Azure AD. So you can customize the picture, the text on the screen. If you're using ADFS, you're not going to see this anyway. It's going to kind of flick it off to your ADFS page if you're external, and you can customize that page. But if you're not using ADFS, definitely set up branding. Verify your domain before you start syncing. Viral takeover I'll go through in a minute, but you want to add your custom domain, so your public FQDN, say contoso.com, add it and verify it to the tenant prior to synchronizing users. The reason you do that is users will end up with the wrong UPN in Azure AD if you synchronize the user accounts up first before there's a public domain to map it to. So they'll end up, all users, with a contoso.onmicrosoft.com as their UPN, as opposed to contoso.com as their UPN, which is effectively their username they're using to sign into the service. If you forget to do this, it's no problem, because when you add and verify the domain, it'll fix up the UPN for you afterwards. But you kind of just want to do it as the first step. Viral takeover, I cover in the next step, but it's kind of bad wording we use. It's an internal kind of term we use. But basically, what it means is, as a user, if you sign up for Power BI, RMS as a user, and your company hasn't actually created or consuming any cloud services and therefore don't have an Azure AD tenant yet, we spin up for that user, based on their email address they're signing up for the service for, a little instance of Azure AD under the covers that will use contoso.com as the tenant name. Now, if contoso.com comes in and buys Office 365, well, there's a problem, because contoso.com already exists in Azure AD tenant for the user. As more users sign up for that RMS service, for example, they'll land into that tenant. They don't see that tenant, it's hidden from them. But as an administrator, I've got a problem now where there's this other tenant with contoso.com namespace in it. How do you deal with that? And as an administrator, you can do that by verifying you're the owner of contoso.com with a DNS record, and basically you can take ownership of that tenant and basically uplift it to a proper Azure AD tenant. Catch is not all services support this, so Power BI is a problem at the moment, but RMS does, where it can kind of transfer the services. But if you ever hear that term, that's what it means to a viral takeover. Sounds suspicious, but it's not really. Make sure your technical notifications go to a DL and not a user, because the likelihood of that user maybe leaving or that email address becoming obsolete is quite high. So all the information about what's going on within the tenant, maybe there's a problem with your ADFS certificates that are upcoming, or just maybe there's something impacting the tenant. We send those email notifications out to that. So you want to make sure it's not going to a black hole. Licensing. Azure AD Premium allows you to simplify the licensing aspect of Azure AD workloads. So EMS, if you want to assign Intune Azure AD Premium licenses, you can do it to a group and do it selectively against a group. That could be a dynamic group built in Azure AD, pivoting on an attribute, or it could be a group synchronized from on-premises, and the membership of that group will reflect license assignment in the cloud. So if I add a user to that group, they'll get the licenses I choose to assign to that group. And if they leave that group, it'll take it away. We've got some nice group-based licensing coming soon as well that will extend to other workloads. But today it's kind of limited to EMS and Azure AD Premium workloads. Because today you have to script it if you want to move into those Office 365 workloads, which gets quite messy. Network prereqs is important, and that really pertains to Azure AD Connect and some of the agents that we deploy with that server as well. So by default, when you install the latest version of AD Connect and a couple of months versions older, we actually ship a health agent with it, which starts to surface synchronization messages in the Azure portal for you. So previously, if a user wasn't synchronizing based on a problem attribute or anything like that, you had to dive into the UI on the sync server itself and try and ascertain what was going wrong. Now the health agent will surface that data for you in the new Azure portal, and will give you insight into users and objects that aren't synchronizing and why. So that agent is deployed by default. But if you don't have the network ports open outbound for it to work, you won't start seeing that data in the new portal. So you want to look and relook at those prereqs. Azure AD Connect itself just has very simple requirements, just port 443 outbound and port 80 outbound just for certificate revocation list checks. The actual synchronization of the user objects always goes over SSL. But if you want to do the agent stuff, there's extra outbound network requirements for that. And also for password write-back scenarios as well. Naming your tenant, this is always, we see this all the time, but when people sign up for a tenant on behalf of the company, don't use something really strange, because that tenant name can appear in important places that end users will see, specifically SharePod Online. The use cases of where this appears is less and less, but it's fine for test environments. For production, use something meaningful. Obviously, the names that are available get less and less as people sign up for these, but yeah, try and avoid things like this for production tenants. Because once you name that tenant, you can't rename that. It's stuck. The only way to fix this is to create a brand new tenant and move all of your services over, which is an absolute nightmare. And we don't have methods to do that nicely for you. So, and also, there's some high-level permissions you can set at the tenant level, which we don't do a very good job of advertising, but if you run this PowerShell commandlet, specifically the get, you can see some of the toggle switches you can turn on or off at the tenant level. One of the big ones is, as a normal user, I myself can connect up to my Azure AD tenant. For example, I can connect up to the Microsoft.com tenant, and I can do a get MSOL user and see every user listed in Microsoft's Azure AD tenant. If I wanted to stop that, you can flick the ability for normal users to see all other users through means like that and through other methods through this PowerShell commandlet. You can turn off things like signing up for end users can enable apps by default and things like that. So there's some, I think 8 or 9 toggles you can set with this that might be prudent just to have a look at that you might want to restrict. You just set them to true or false. They're all set to true out of the box. This is just a badly animated slide on the viral tenant process I just touched on. So someone comes along and signs up for the RMS, which you can sign up for free. Obviously, to use RMS's rights management service, so I can basically protect documents in transit and at rest. Obviously, to use RMS, it's got to come through Azure AD to function. So the end user, we kind of hide that sign-up process and we just give them access to RMS, but under the covers, we've spun up an Azure AD tenant, which is the on Microsoft. Anytime you see on Microsoft.com, that's an Azure AD tenant underpinning. Everything else sits on top of that, Intune, Office 365. Another user from Contoso.com signs up for it, and because he's got the same email address, he'll just go into the same viral tenant. And he's got no awareness that there's a tenant here at all. He just wants to consume the service. But an administrator comes in for Contoso.com and now wants to buy Office 365. And we have a problem because they can create the Contoso.onmicrosoft.com tenant, which is the name that we control. But as soon as they try and add Contoso.com into their tenant, there's a conflict because it already exists in the other Azure AD tenant, this free one we spun up behind the scenes. So for the administrator of this tenant to remove that Azure AD tenancy or uplift it and kind of bring it into theirs, what they do is they add a DNS text record for Contoso.com because this administrator presumably has access to create a record in the public DNS zone. And by doing that, Azure AD will confirm that this user owns that domain and will basically move the users over and kind of uplift that tenant. And in this case, the service will come across in RMS. Power BI does not come across. So if you've got this scenario with Power BI, the same concept, you have to basically delete the Power BI workloads and bring the users across and kind of re-import it again. It's a nightmare. So be careful when users are signing up for kind of those free services, because under the covers, there's an Azure AD. You kind of want to bring those services into your production tenant. Sync and auth. So how many in this room are still using DirSync? The older DirSync. You need to get off that soon. So the historic nature of our sync services was back when we released BPOS, our first iteration of the cloud, we had DirSync. That was superseded by Azure AD Sync, which has since been superseded by AD Connect. We also have, years ago, dealing with multi-forest environments, FIM with an Azure AD connector. Azure AD Connect can now do multi-forest environments. So the one sync server, which is Azure AD Connect, is the latest one. That's where all investments are going. But the wizard allows it doesn't include ADFS within the sync process, or it doesn't provide authentication, but it facilitates setting up the synchronization process. ADFS, if you want to, it'll help you configure and set that up, or some of the newer authentication methods, which is password hash sync, pass-through authentication, and seamless SSO, which I'll get into, and also the health. So it's basically the one go-to tool instead of all of these other tools that used to exist, and it got very confusing. So you just basically download Azure AD Connect. The good thing about this tool is it's self-updating. If you do the Express installation, where you just accept all the defaults, you can turn on the self-update mode, and as we release updates to the tool, it'll just update itself to the latest version with bug fixes and enhancements. If you choose the custom installation mode, it excludes you from taking advantage of the auto update feature, which isn't a bad thing if you're in custom mode, but you just need to be aware of that nuance. Yeah, so it's designed to simplify. Most customers just default to the Express settings, just go next, 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 and you're done. It's fairly trivial to set up and use. And yeah, all of our investments are going into the improvement in this tool. All of these other ones are dying off. And specifically, if you're running DirSync or AAD Sync, they're going to fall end of life this April. And by end of life, what they'll end up doing is turning off the endpoint that those two particular sync engines can talk to. So they'll just stop syncing at all against your tenant. So we have, to upgrade to AD Connect, you can actually do in-place upgrades. It depends on the number of objects you've got synchronizing. So you can do an in-place upgrade, or you can do a staging server, which is a new AD Connect server with the same configuration as your DirSync AD Sync server. And that you take, when you're ready and comfortable that that's configured properly, you take it out of staging mode, and that becomes the authoritative sync server, and you just turn the other one off. You can't have multiple sync servers synchronizing at the same time to the one Azure AD tenant. Any questions on this?
What is the guidance on the staging service now with stuff like PTA?
I'll go into that in the next slide if you want, but yeah, I'll go into the nuance. There's some real, they're cool features, but you need to know the caveats that can catch you out if you choose to go those routes, because certain things don't work if you do go those new routes. But they are definitely...
So sorry, you're asking a question around HA specifically? So,
not really.
For the sync engine?
Yes.
Yeah, so there's no real HA today. Yeah. It's a single server with a other server in standby mode, in staging mode, and if the main server blows up, you take the other one out of staging mode. The good thing is, unless you're doing a lot of changes or user creation, no one really knows when the sync server's dead, unless you're doing password write back. And that's where it becomes critical. But outbound sync, I've seen a customer with it offline for a month and they didn't even know. But that's where AD Connect Health, which surfaces that data about the sync server itself, can send you alerts. That's why setting the technical DL email, or the email notifications to a DL, is critical, because if we don't detect a sync cycle from your server in 24 hours, we start proactively emailing you saying you might want to check on this. But yeah, there's no HA, but there are plans to have HA capabilities coming.
But the standby nodes also has auto update feature?
That's a good question.
yeah, it does. Yeah.
It does?
Yep. Really, the way to think about standby, all it's doing is everything that the other node is doing, but it's not exporting any of those changes into either Active Directory or Azure AD.
Okay, authentication. So we understand a lot of people are using ADFS today, and I think that was either they already had ADFS deployed, or it was the only option where if you want to provide users a nice experience to sign on using their same credentials, not handling another set of credentials, it was the only way to do it. But we have some new ways. Well, password hash sync isn't a new way. That's been around for a while. But that was your other choice with authenticating. So basically what we take is the password hash from Active Directory, hash it again. That second hash was what was replicated up to Azure AD, and the authentication endpoint was Azure Active Directory at that point for the end user. So they would just sign in with their same credentials that they were using on premises. And if they changed their password on-prem, we would replicate the password change real-time to Azure AD. By real-time, it's within a 2-minute window from that change being reset on-prem to replicate to Azure AD. We announced late last year pass-through authentication, which I'll go into what that looks like. This is still in preview. And seamless single sign-on. These three together really negate the need to do federation, ADFS or third-party STS ping federator, a SiteMinder or anything like that, unless you've got particular requirements to do so. So the way to look at these is they're meant to be used together, and I'll go into why, but the one that can only really be used by itself is the top one, password hash sync. And the main reason is that seamless single sign-on only caters for users within the corporate network that have line of sight to a domain controller, and pass-through authentication allows a user outside the corporate network where no password is stored in Azure AD to authenticate. Question?
I've seen it working with cache credentials as opposed to.
Which one?
Seamless single sign-on when not on the corporate network.
Cache credentials. So as long as you're...
So there's a bunch of stuff to understand around the tokens that are involved and what might be stored. So for example, even some applications might have a session that's maintained outside of Azure AD. So it's a fairly complicated area.
Also, there's a checkbox as well if you keep me signed in that can really skew the what we remember and the length of time we remember that session, which helps with an SSO experience, but can also lead to, well, what's going on here? Yeah. Sorry, Jeff.
Yeah, that's right. Yeah. So I think the technical answer is if you have cleared all your browser history, cached cookies, those sorts of things, you shouldn't be able to use your cache credentials on a Windows desktop outside the corporate network to seamlessly sign in. No, but that's that there are other conversations around Windows 10 and Passport for Work, and so it's a complex kind of area to give you an answer.
So password hash sync, for those of you who don't know, and I kind of touch on there, we take the password hash it again, Azure AD replicates that up. That falls out of the normal object synchronization cycle, which is now once every 30 minutes used to be once every 3 hours with the older versions of the sync engine. Now it's once every 30 minutes, but password syncs is out of that window. So it can be, it's very quick, but if you're doing lots of password changes, it depends how many we can, because they're put into batches of 50. So if there's been a huge amount of password changes, that can impact the speed of time those changes get replicated to Active Directory. But if you just go change one user's password, you'll see it appear or synced up into Azure AD probably within under 30 seconds. You can look in the event logs and monitor that sync process. But for the user, what this means is they're signing in against Azure Active Directory. So there's no on-premises requirement that can impact, or there's no HA requirement or any type of on-premises downtime that can impact a user from signing into the service because they're using the global entry point of Azure AD. So even if that Azure AD Connect server goes offline, they can still happily sign into the services, no problem, which they can't do if ADFS goes down.
Does it sync the entire Active Directory, or can you point it towards certain containers, say if you've got service accounts that you do not want?
Exactly. You can scope AD Connect to say, just give me users from this particular domain, if you've got multiple domains, or from this OU, or this group. The group option's really only meant for testing, not for production, or you can do it based on an attribute. So you can get quite granular. And there's some accounts we just don't sync by default anyway. The built-in rules will not bring across those system accounts and protected accounts anyway. But absolutely, you can scope it. So we recommend this when you just want a simple way to get going. For an end user, the experience is kind of the same with ADFS. If I check the box to keep me signed in that we just touched on, you're getting an SSO experience for the life of your password until you reset it or clear your session and cookies, whether you're internal or external. Pass-through authentication is basically built on a connector, the same concept of basically app proxy, how that works. You deploy a connector or more than one connector on premises. That connector talks outbound to Azure Service Bus, which is created specifically for each Azure AD tenant when this is created. And what this means is I don't need to synchronize any concept of a password or password hash to Azure AD for those customers that didn't want to do password hash sync for that very means. So there's no concept of a password stored in Azure AD. But as a user, I go to the sign-in page of Azure AD. I put in my username, my user principal name, and my password. And we send that password down to the connector on premises securely. That connector talks to a domain controller and tells Azure AD if that password is correct or not with a simple yes or no. If it is, the user's auth. We accept that message back from the connector and let the user in. So at no point here is any password stored in Azure AD, but I can sign in with my on-premises credentials.
Question before about the cached credentials. So does the pass-through authentication and seamless sign-on work with direct access when they're outside the organization?
So seamless sign-on only works when you've got line of sight to a DC. So if I've got a VPN active or direct, as long as I can talk directly to a domain controller, seamless sign-on, Kerberos or auth basically will work. As soon as I've lost connectivity to a domain controller, that's where pass-through auth caters for that scenario. So that's why you deploy them together. So when you fall outside of that corporate network, you can still authenticate to the service or through the service using on-prem credentials because we're funneling that traffic down to the connector on-prem, which is going to confirm your credentials to a DC for you. Does that answer the question?
Would that connector work with a trusted domain? And would it work with a trusted Kerberos realm?
So the PTA one works, I think, cross-forest, doesn't it?
Yeah, so PTA just requires connectivity to a domain controller in the domain you're trying to authenticate the user for.
That domain or a trusted domain?
The domain that the user resides in, it doesn't need to be a trust. Whereas the SSO experience requires Windows authentication to work, which does require a Windows trust to be in place between the forest. So you're going to have AD Connect is going to be either installed in a forest or not installed in a forest. But in the case of doing the Windows, the seamless SSO, it needs to be in a forest and it needs to have forest trust to all the user domains that you want to authenticate users for.
Okay, so the reason you do this is you don't want to do password sync and you want to keep the on-premises server footprint light. So ADFS requires server infrastructure, load balancing, certificates, etc. This just requires agents that can be installed on existing servers that have line of sight to domain controls. You don't have to put them on dedicated servers, virtual or physical. They can just go on existing member servers. The requirement is it just needs to be Windows 2012, I think, as the base operating system for those connectors to work. These are the catches. So pass-through auth only works for modern authentication clients. So that instantly rules out ActiveSync, which uses legacy authentication, basic auth, which also rules out anything Outlook 2010 or lower. Because this doesn't understand modern auth, which is an Office 2013 and higher concept. So if you need to cater for older clients or for ActiveSync clients, you can't really use pass-through auth exclusively. And that's why you would turn on password hash sync as well as pass-through auth, because if pass-through authentication doesn't work, we can fail over to password hash sync, because we've got a version of the password in there that the user can authenticate, which will allow these to work as well. But if you didn't do password hash sync, you would instantly prevent these from working.
There's some other reasons to sync the password as well. So we have some security features around identifying known compromised passwords. That if you're syncing the password hash, we can apply those security mechanisms. Also, other security mechanisms around causing an auth challenge when someone changes their password and things like that.
Okay, this is seamless single sign-on. It used to be called desktop SSO. In fact, I think some documentation out there still refers to it. So I don't know why they renamed it. They literally called it something else the day they released it, where the day before they were still referring to it as desktop SSO. And really, all it is, when you enable this box in AD Connect to turn it on, it creates a computer account in the domain. That computer account has an SPN or an SPN set on it with a couple of URLs referencing the single sign-on URL of the service. And what happens is when a user tries to sign on, so if I'm already logged onto my desktop on the corporate network, I try and hit portal.office.com, we get a 401 challenge to say, please authenticate. And because the URL is returned resolved to a computer object with an SPN set on it, we go off and basically get a Kerberos ticket from that computer account. The computer account has its machine password synchronized through AD Connect to Azure AD. So when the Kerberos token is wrapped up in HTTPS and sent back to the service, we can decrypt the token and the password and prove that the user performed Kerberos authentication and let them in the door. So basically they get a true, today it's not really true SSO because it doesn't do home realm discovery. You've still got to input the user principal name. As soon as you do that, it kicks off and you're never prompted for a password. They're looking at fixing that so you won't just basically get a prompt, or if you're logged onto your desktop, you've got this set up, you'll just be true single signed on to the service. So some pluses here is no extra hardware, it's a computer account. This is just leveraging your existing domain controller infrastructure and AD infrastructure to work, as it's just Kerberos. You have to have line of sight to a domain controller. Outside of that window, that's where pass-through auth or password hash sync would kick in. And again, only supports modern auth and some browsers. Doesn't work for Edge, for example, funnily enough. And obviously Kerberos capable operating systems. And lastly here we have federation. So this is the traditional ADFS model where you're synchronizing user accounts. You can synchronize password hashes under the covers as well when you're federated, but at the top there you would have your ADFS infrastructure. And that would be a minimal, ideally a 4-server footprint, 2 public-facing web application proxies load balance, 2 ADFS servers in the farm internally. So you're catered for any type of outage or providing HA. But in the event that ADFS went down, this is why we kind of recommend turning on password hash sync under the covers. You can flip the domain to unfederate it and instantly move the authentication traffic to Azure AD, where we've got password hashes to cater for user sign-on. And this is a way to move off of ADFS as well if you wanted to. So the reasons you choose ADFS, if you didn't want to do any type of password sync, but PTA kind of caters for that need now, and you just want to keep the IDP, the identity provider, under the organization's control. You wanted to do you can do crazy stuff with claims rules. So if you wanted to do conditional access at a much more granular level, but with much more complexity, you can do that there at ADFS and also with third-party interop, or you might have just already had it in place and don't want to move away from it. And it's a requirement. Anyone play with device registration in Azure AD? Yeah? So one of the caveats with this is if you're catering for Windows 7 and 8 clients, for them to register themselves against Azure AD. And the reason you'd register a domain joined computer against Azure AD is to use the conditional access capabilities of the service, where we can distinguish if a computer is domain joined or not. For that to work for those operating systems, it currently requires an ADFS infrastructure to register against Azure AD. For Windows 10, you don't need ADFS at all. It'll register itself, whether using pass-through, auth, or password hash sync, etc. That's going to go away as well, where they'll fix it to work with seamless SSO. So auth do's and don'ts. Try and choose the simplest method for your need. Don't overcomplicate it. You can change it afterwards. You're not glued and stuck to one method. So if you do choose ADFS but want to back out of it, you can do that. If you choose password hash sync but want to go ADFS, you can do that as well. If you want the best experience, regardless of the option you choose, Windows 10 is the way to go. So if you do Azure AD join, you really get the best SSO experience, because it's basically truly integrated with Azure AD at that point. And signing on to the desktop really gives you no prompts. Whether you sign to the desktop with a password or Windows Hello, from that point on, your journey through Azure AD and any services backed by that, you'll never get a password prompt. Any operating system below that, it's a bit kludgy and hit and miss. But Windows 10, whether it's registered with Azure AD or Azure AD join, gives you the best end user experience. And this is where they keep improving on that.
Any branch requirements there?
Any what?
Windows 10 branch requirements?
I don't believe so, no. So Azure AD join was just a capability out of the box, but that has improved as they've added the newer builds. I don't know if...
So there are a bunch of features in this space on the roadmap, though. So I guess Ben and I aren't really across the Windows 10 stuff as well as we are across the identity platform stuff. But I know that there's a lot of scenarios that we're starting to enable that maybe you won't get if you're in one of the branches that doesn't get the updates as quickly. So there may be, but the fundamental functionality Ben's talking about is there from RTM.
Yeah, know which clients and scenarios and applications support which means. So remember the legacy auth, the Outlook 2010, the Exchange ActiveSync clients. Know which will break if you choose one method. Understanding single sign-on versus same sign-on. So this catches up a lot of people where they say, I want single sign-on. So they deploy ADFS and they find out soon enough they don't get single sign-on under certain scenarios. And those scenarios would be when I'm outside the corporate network, I'm getting a forms-based page presented to me by the external ADFS web application proxy servers. So I'm not getting single sign-on at that point, even with an ADFS infrastructure I've built out. Whereas same sign-on is the concept of I'm signing onto the service with the credentials I already know, username, password from on-premises, and I can check the box that says keep me signed in, and then I'm getting actual SSO from the get-go. Or I've got the Windows 10 Azure AD join scenario where I'm getting it out of the box regardless of what auth method I've got. Enable password hash sync, even if you're federated, and that's what Jess mentioned, where you can leverage the leak credential report if you're using Azure AD Premium, where we can kind of map that to password hashes if an account's been compromised that we're aware of, and we can alert you of that and you can action that. Or if you're using identity protection, you can action it through that means. If you're federated, make sure you've got a global admin account that is unfederated. So the default on Microsoft domain. We've had a lot of people, once they've either removed this account, federated, and if ADFS goes down, you're not getting back into the portal until you fix ADFS. Whereas this gives you a ability to log into the portal and fix things, maybe change your auth method, but it just gives you that flexibility of fixing things and not locking yourself out of the portal. Always leave that at least one global admin account to log in with. And obviously add MFA to it, etc., being a global admin account, but yeah, that's caught a lot of people out. Don't deploy to ADFS. Definitely deploy it if you see use cases for it, you have requirements, just don't default to it. And there's some advantages to ADFS as well. In ADFS 2016, for example, you can sign in with multi-factor auth as your primary auth method over a password. So there's some definite advantages there, but just don't default to it. And if you have deployed ADFS, don't forget about signing certificates rolling annually with a default installation of ADFS. So we create self-signed certificates, which basically sign the tokens that go to Azure AD. If those self-signed certificates roll, which they do automatically, the new thumbprints don't automatically get pushed to Azure AD, especially if you don't expose your federation metadata endpoint to the internet, where Azure AD can proactively check and pull those thumbprints. So effectively what happens is ADFS gives the user a token signed with a thumbprint that Azure AD has no idea what it is, so it doesn't let them through the front door of Azure AD until you push the thumbprint. How you push the thumbprint is by running PowerShell. I think it's update-msol federated domain for the domain and pushes the new changes up to Azure AD. Again, if you're using Azure AD Connect Health, this will give you insight into that and awareness and fair warning. And also we email you when we know they're going to expire as well. Sync do's and don'ts. Plan your upgrade so you can do it in place under certain scenarios, or use a staging box. Deploy the health sync agents. So the sync agent deploys with the AD Connect server, but ADFS and Azure Active Directory on-prem, we have agents for those as well. So you have the rights to deploy those if you're premium, where you surface that monitoring and health data for all of those on-prem resources in the Azure Blade, which I'll show you in a sec. Scope AD Sync. Don't use this as a good means to start cleaning up what's going to the cloud. From your on-prem AD might have a lot of historical data in it that you might not want to replicate to Azure AD. So it's your opportunity to synchronize a nice clean version of your AD to Azure AD. And again, you can scope AD Connect to nicely do that. By default, if you don't scope it, it's just going to do everything in the forest that falls under its rules. The concept of a consistency GUID kicks in if you're dealing with multi-forest scenarios. I'll go into that in a minute, but that's an important consideration, especially if user accounts are going to move between forests. Understand password hash sync and password write back and the requirements for that. Again, it comes down to doing the network requirements just for AD Connect itself. And around the directory size. So if you're out of the box, we'll let you sync 50,000 objects to Azure AD. If you add and verify a domain, it automatically raises that limit to 300,000 objects with no extra engagement with support. That just happens when you verify. If you need to go higher than that, you need to open a ticket with support where they'll raise it even higher. They're pretty corner cases for Australian customers. But the sync server itself, it installs with SQL Express, and the database with SQL Express basically won't go higher if it's got 100,000 objects within it, which forces you to install AD Connect with full-blown SQL. So if you're under that, and that's a good reason why you might want to start scoping to keep those object sync size down or the sync count down. And you can run a tool called ID Fix, which gives you an idea of everything that falls into the scope of the sync engine to get an accurate count of what's going to sync and also what needs to be fixed on-prem as far as attributes go.
If you are going to filter to reduce the database size, you have to be aware of the type of filtering that affects database size. So if you filter by domain or OU, it won't end up in the database. If you filter by attribute, it'll still go into the database. So just some considerations.
Nice one. Don't force either password sync or a full object sync. You don't really need to do that. We found people were doing this on a scheduled basis. It isn't really required unless you're trying to troubleshoot something. So just let the thing run. First time you install it, it does a full sync. Subsequent syncs are delta syncs. Password syncs are obviously kind of deltas as well, real time. But the service will actually throttle you if you start trying to do full syncs all the time. You can end up kind of preventing a sync from happening at all for a period of time. So just set it, forget it, unless you're working with support, where they'll tell you if a full sync's needed or not. But don't trigger this stuff all the time. And don't leave the sync UI open, because that'll break in-place automatic upgrades, or if you're trying to upgrade itself manually, if the UI is open, it'll throw an error and won't upgrade. So this is just quickly on the consistency GUID concept I touched on. So you install AD Connect. It replicates the users from on-prem to Azure AD, and one of the defining attributes it looks at to map that to a user or to the user it synchronizes is the object GUID of the user in the on-prem AD. That's an attribute that we kind of have great confidence in that we know won't change for the life of the attribute, even if you rename the account, etc., unless you're going in and touching the attribute with Add the Edit or something like that. And that really is a hard one-to-one mapping then. When we replicate this user, we link it to the object GUID. If you have a second forest in the picture, and the one sync engine is synchronizing users from those forests, and these numbers here represent what value sits in the object GUID, what happens is if you then move a user to the other forest, that user is going to get a different object GUID, which means the sync won't be able to map it to the original object, and you'll end up with a duplicate account in Azure AD. So the way we recommend approaching this is from the get-go, change the default rules in AD Connect from the object GUID to another attribute you've got confidence in the value in that won't change. So if we do this again, this is where you do it in the AD Connect setup. You can change we call it source anchor, which is looking at the object GUID. That becomes the immutable ID in Azure AD if you dump it out through PowerShell. So if we go through this scenario again where we're not doing object GUID, and so what we do here is, in this example, we're just putting the same value from the object GUID but into another attribute, and AD Connect is syncing that other attribute and mapping it to the immutable ID in Azure AD. But now when this user moves across, they've got a new object GUID, but they've still got their old one in the other attribute that does map to the same user, so you won't end up with a duplicate account. Now you want to do this before you start synchronizing, because once you synchronize the object GUID to Azure AD, it's very difficult to change the object in Azure AD, especially in bulk and especially if you're federated. You basically have to unfederate the user to change it. You have to flip their UPN to then change it and then flip it back again. So it's an outage and it's a nightmare. And the service will throttle you if you've got lots of users. So this is something you'd think about doing before you set up AD Connect, catering for multi-forests. And don't believe if people say we're never going to move accounts between forests, don't believe that, because they will end up moving at some point. This will cause no end of problems in Azure AD as a result.
20 minutes.
Okay, cool. So Connect Health, I'll do a quick demo of this. This is agent-driven on-prem agents that you deploy. Again, use the concept of Azure Service Bus to basically dump the data it's collecting into a secure storage account, Azure Storage account, that then is linked to your Azure AD tenant. You don't really see that or have any control over that, but it is linked and only used for your tenant. And then we bring up that information about monitoring and the health of these environments in the portal. So there's a lot of investment going into this. So today you can do ADFS in preview for on-prem AD, and obviously it ships by default with AD Connect. So for those of you that are running ADFS, this really gives you a good insight into the auth traffic that's hitting the internal ADFS servers versus external, the reliant parties that are being touched, the auth method users are using, whether they're doing MFA or Windows Integrated Auth, etc. So it gives you that good insight into how busy and healthy your ADFS environment is. Easier to onboard as long as you've got all the outbound requirements. There's no inbound port requirements, but as long as you can get this traffic out through your proxy, there's a few outbound ports, it'll just start to work. I'll just skip through this. Once the outbound connection is established, but you don't need to punch a hole. Yeah, exactly, yeah. So let me just show you what this looks like. This is, for those of you who haven't logged in, this is the new Azure portal, portal.azure.com, where we have Azure AD up there now. It was missing for a while. So you add the Connect Health blade, and I'm monitoring my environment, so I've got ADFS with a warning against it. I've got my sync environment monitored, and you can see I've got a sync error there, and I've got my Active Directory on-prem AD being monitored. But I can go into my ADFS environment. I can look at the warning, but I can have a look at the authentication traffic going against my internal ADFS servers versus my external web application proxy. I can see based on relying party trust, the traffic, the breakdown of traffic, and I can see some things like who are the top 50 bad users that are doing bad password attempts. So if you don't have soft lockout turned on your ADFS infrastructure, this is a good, first of all, you should have that turned on so you don't prevent lockout of your internal AD account, but this really gives you good insight into, again, if an account's been compromised, you can see who's hammering the external ADFS server with failed password attempts and then action that on the user. And sync errors, I can have a look here and see what might be going on with the sync engine, why something's not replicating. And I've got a user here that's not replicating, and it tells me why, and it's got a duplicate proxy address. So it's taken one user off, it's synchronized one user, but it's preventing the other user object from coming across because there's a duplicate proxy address that's been detected. To find this out, previously you had to dive into the sync UI on the sync server engine, and it was a nightmare. Whereas now you can do this. And you can delegate the blade to your monitoring team and set up alerts to get emails about things that surface here. Connect health do's and don'ts. So deploy all the health agents. Again, you need premium if you want to deploy ADFS and the domain services agents, but sync services, you don't need premium to leverage that. Get onto the latest version of AD Connect, delegate the health portal, and obviously follow the suggestions of the health agents. So these are always being improved, and those agents are self-updating. But you have to turn that on in the portal, and once you do that, you just set and forget those agents. They'll just get the latest version, and we'll push them down. Active Directory health agents will give you insight into replication, logon type, all the traditional AD stuff. And don'ts, not deploy the agent. And if you've got password write back, we don't have a method to monitor that yet with the agents. Self-service password reset. Anyone using this today? How are you finding it?
Mostly good.
Yeah? What's with the
You tick the box to say force the user to reset their password and break the sync.
okay, yeah, from the get-go, yeah. So the premise behind self-service password reset is to allow users to use their Azure AD portal. So I don't know if you guys have ever logged into the end user portal. It's called myapps.microsoft.com. As an end user, I can go in there and if I know my password but I want to change it, I can change it and have that change written back to on-prem AD real time. If I've forgotten my password, I can go to another portal, and the user would have to be registered for this process, but I can prove who I am as a user because I would have had to have set up an alternate verification method, which was either responding to an MFA challenge or an alternate email address. And I can reset my password through that method and have that updated to the on-prem AD. So it allows users not have to come onto the corporate network, but allow that password management, take that strain off the help desk and just move it to the users. It is a premium feature though. So if you've got synced users, you need password write back enabled to really make this effective. And again, it utilizes Azure Service Bus. So when you check the box in AD Connect, it connects up the Connect server to the service bus of the Azure AD tenant. Again, this is a terrible animation, but it's just showing you gluing that AD Connect server to Azure AD and allowing that traffic. Again, it's kind of the concept of the outbound traffic. You don't need to expose the Azure AD Connect server directly to the internet. reverse publish it to allow this to work. And then that user down there can reset their password. And again, have it written to the on-prem AD. Do's and don'ts. So probably the big thing around this is end-user comms. Because what you want to do is, once you enable it, or the other big thing here, this will work. A common misconception is password write-back won't work if you're federated. We don't need you to be syncing the password to Azure AD to allow a user to reset their password and have it written back to on-prem. It'll work if you're federated. But what you want to do is basically end-user comm, get executive sponsorship, and start by restricting access to, roll it out slowly so you can restrict access to a group or a series of users, and then get a feel for how it's going and open up the self-service password concept. Kind of just don't turn it on for everyone at the get-go. It gives you a way just to troubleshoot and just get a feel if users are getting the hang of it. And you want the users to, you want to check this box in the Azure portal which says users need to register when signing in. Because if they've been added to the group for password reset, the next time they sign into any Azure AD backed service, they'll have to go through this registration process to put in an alternate verification method so they can use the lost password concept in the other portal to prove who they are, to then reset their password. And the logical thing to do is kind of deploy this alongside an app a user wants to use. So if they Office 365 and they're using Exchange Online, you can tie it in when they're trying to hit that, they'll be forced to register. They have to register the one time and they're done. And what you can do is build an SSPR site, something like this, where they can just go to a website. You can direct them to and say, okay, what do you want to do? Change password, reset your password, or register. And we've got a sample of this on the Azure AD documentation site, and it'll just take them off to the relevant link. And just some notes there is testing with a admin account. So MFA, I'm just going to hand over to Jess, who'll do the MFA.
Okay, guys, so we're going to talk about a couple of things here. MFA, conditional access, and identity protection. They all kind of fit together. So we'll kick off our MFA capability. It's cloud capability sits up there with Azure Active Directory, and fundamentally it allows us to create a multi-factor auth challenge for users accessing applications that are enabled through Azure AD. So that's all of our SaaS applications, Office 365, potentially application proxy, which I'll talk about as well. And so users go through their normal login process. They hit ADFS and they authenticate against ADFS using either the form or Windows authentication. Credentials are verified against Active Directory, and then they sign into Azure AD. At that point, we can trigger a multi-factor auth challenge. Now, the types of challenge that we can do with Azure MFA, the phone integration, so we can have a telephone call or a code or one-time password sent to via SMS to the phone. But I guess our preferred method is with our Authenticator app. And the nice thing about the Authenticator app is, some of the security features of it, but also the user experience. So, on iOS or Android device with biometrics, for example, you get a challenge that pops up on the phone, you can touch the Touch ID and you're signed straight in. So that's one of our challenges with MFA is that we want to improve security, we want to reduce reliance on credentials and the risks that go along with those, but we don't want to impact user experience too much. So user fulfills that challenge and they can sign into their applications. Now, when we're thinking about do's and don'ts, so we've got a couple of deployment options. What we showed in the slide was our cloud-based MFA. We also have an on-prem component. Now, the reasons for deploying the on-prem component in the past were, what are the applications and services that you're trying to enable? If they're all Azure AD applications, then there wasn't a lot of difference between the two. But if you had some on-prem applications, Radius for VPN, those types of things, the only way that we had to enable that in the past was an on-prem server. Now, the problem with deploying the on-prem server is that it's not tightly integrated with our cloud capability, and when we start talking about conditional access, it's a bit more complex. You have to integrate it with potentially your on-prem federation capabilities and things like that. So with our cloud MFA, what we're doing is starting to enable the scenarios that we would previously have deployed the on-prem MFA server. So things like Radius, you may have seen we now have in public preview extension for the Windows Network Policy Server component that allows you to do Radius authentication against the cloud-based Azure MFA directly. So you don't need the on-prem server component and the registrations and things like that that go along with that. Additionally, we have in ADFS 2016, we've got the ability to leverage cloud MFA as opposed to requiring the on-prem MFA server to do MFA at ADFS. And Ben talked about some of the nice capabilities around doing MFA as a primary authentication. So if you've got a shared kiosk machine or something, people can just walk up to it, put their username in, get an MFA challenge on their device, and they're authenticated in the browser. They haven't had to enter their credentials in. So there's some nice scenarios that we can enable now with cloud MFA that don't require those on-prem MFA. So know how to troubleshoot MFA authentications. There's a few points here around how modern authentication works versus legacy authentication when MFA comes into play. We've got a link here in the deck to a debug tool. Fundamentally, understanding that flow for modern authentication is going to be really important for troubleshooting. Which applications will share SSO, which applications will share the MFA session. There's some differences per platform, so things like iOS and Android. There's some requirements to share the MFA session between the different apps. So there's a bit of understanding. There's some good documentation in that space. So use the mobile app over SMS. So there's a couple of reasons for this. One, obviously, is SMS has been deprecated by NIST as a recommended second factor. We still have the support for it in our platform. We do think that it does improve security, right? It's better than not having a second factor. But there's enhanced security through leveraging the mobile app. But the main thing is as well, or the other significant factor is the user experience. So you just get a better user experience using the mobile app. Okay, use conditional access. Now, we want to prompt our users less for MFA. By using Azure Active Directory Premium and conditional access, we can create a policy per application that allows you to say when to trigger MFA and when not to. And you can take into account things like the device status. So is this client compliant with our MDM security policy, or is it a domain joined client that we've got group policy applying to, enforcing BitLocker and those types of things? If it is, maybe we don't need to require MFA. Is this application a low-risk application? We don't really care if the user does MFA or not. So we can reduce the amount of prompts for MFA by using conditional access and defining that policy while still maintaining our security posture. People are much less likely to do silly things if you give them good user experience. And consider using identity protection. So this is another factor that can come into the equation when challenging users for MFA. So not only where are they coming from, what are they accessing, but what's the risk associated with their authentication. We'll talk about identity protection in a moment. So don't assume users and business units will understand why. And this is a factor about improving the user experience. And organizations will come at this from different angles. Some organizations just don't allow anything externally. So it's an improvement for users to now allow it with MFA. But for people that already have access to stuff, to throw MFA on top of it can create some resistance. So consider that with the deployment. And so conditional access. This is a really powerful feature of Azure AD Premium, and it comes in the form of policies. I'll get Ben to fire up one of the policies in a second, but essentially what we can do is apply a policy to one or many applications, and we can look at who the user is based on their group membership, and we can define group membership through dynamic groups and and attributes. What's the device they're on? What's the platform, the OS? Is it compliant with our security policy? Is it part of our domain? What's the app, obviously? Where are they coming from? Are they at work, or are they coming from somewhere outside work? And what's the risk associated with this? For example, are they coming from a known botnet? Have they done some impossible travel or something like that? And then we've got actions that we can take. So we can just grant access to the application. We can enforce MFA. And that MFA session is shared between all the applications. So if I've already done MFA for application X, when I hit application Y, if the conditional access policy says require MFA, then I'll get straight in. But if I hit an application that doesn't require MFA initially, I can sign a username password, and then I hit the next application, I can then be elevated, be challenged for MFA at that point. Or we can block. So MFA, test configuration and test environment, and this is something that we would advocate in general. You guys should have a test Azure AD tenant, and if you're using Federation production, you should have Federation in that test tenant, and you should be able to test these scenarios. Tri-phase rollout. All of our policies can be scoped to users, to device types, to applications, and we can roll them out in a controlled way rather than trying to apply it across the board. Understand the authentication flow experience. So it goes back to understanding the different applications, modern authentication and legacy authentication, active sync, things like that. What's going to be impacted, what's not, and how do we communicate that to our users? Understand a policy on a service will apply to all apps that call that service, right? So if you've got something that integrates with another application, if you block access to that dependent application, then you might as well block access to everything. So for example, Skype client talks to Exchange to look up the GAL. If you block access to Exchange, then Skype's going to be throwing errors all the time saying it can't hit Exchange. There are other scenarios where that might come into play, so just make sure you're testing your policies and understand the impact. Use Azure AD CA over ADFS rules where possible. So ADFS allows you to do some conditional access stuff. It allows you to determine whether or not a user can authenticate to Azure AD, but it can't really be granular between the applications that you leverage from Azure AD. But it can take into account things like network location, stuff like that. But once you do that, that change impacts everything that you're using in Azure AD. So much better to use Azure AD conditional access, which gives you that granular control at a per application level. Have an account excluded from all app policies. So this is about locking yourself out, and it comes into this one. Don't apply policy to all apps for all users because you may lock yourself out of stuff. So Azure AD application proxy. Now this comes into play with that previous conversation as well, because if we've got this nice way of controlling access based on user, based on the authentication type, device, network location, etc. We want that applied to more than just our modern authentication applications like our SaaS apps and Office 365 and the custom applications that we built in the cloud. We want that to apply to our on-prem applications as well. So Azure AD, your basic and premium include this capability called App Proxy, and essentially App Proxy is a way of publishing web applications to the internet using Azure AD as the pre-authentication capability. And the way we do this is we have some on-prem applications. We've got some clients that are in the cloud or on-prem. We've got, previously we were probably publishing it through some on-prem WAF. But with Azure AD, we want to make these applications on-prem seem like SaaS apps. So we have a cloud component for Azure AD application proxy, and this is it's a cloud service that's in a bunch of different regions in the world, around the world, so optimized from a network point of view. We want that app proxy capability to be able to connect to our on-prem applications, so we leverage connectors. So we install a Windows service on some Windows servers that are in a network location that they can hit the web apps that we want to publish, and we can have a number of groups of these. So if you've got some apps in a Sydney data center, you've got some apps in a Seattle data center maybe. You've got different security zones. You might have a number of connectors in each of those different locations or logical locations. And they create an outbound connection to the Azure AD App Proxy component. We configure the applications we want to publish. We configure things like Kerberos constrained delegation to give us Windows authentication single sign-on. And we publish those applications. So we've got a number of apps over here. We've got another connector group with some other applications. And the users can hit Azure AD, authenticate, and then our conditional access policies can apply. So we can say for this application you need to do MFA, for this application you can only do it from a compliant device, and the Azure AD will proxy those authenticated sessions through to our applications and potentially do Windows authentication to give you single sign-in to these apps. Okay, so app proxy, understand the connector group model. So this is really around, we need more than one connector for resilience. We need to have those connectors in a location where they're able to connect to the applications on port 80, port 443, but they also, we want them to be close to those applications from a latency point of view, etc. Onboard new apps into their own connector group to start with, so we can understand the impact of those applications, the throughput and those types of things. It allows you to segregate stuff while you're testing, and then you can consolidate later. Set up proxy connector service. We need to have multiple connectors for load balancing and redundancy. Don't place the connector in the DMZ, because then you have to punch a hole through the DMZ to the application. You want it to be in the close proximity to the application you're publishing, and it needs to be able to talk to the domain controllers if you want to do the Windows authentication, the Kerberos constrained delegation. Don't forget about pass-through scenarios where we don't want to do pre-authentication. And then don't forget about hyperlinks to other internal sites. So URL rewrite type capabilities. At the moment, we will dynamically rewrite URLs for other applications that we're publishing. But for applications that we don't want to publish through this mechanism, we have a preview feature that's coming, but consider what's coming through, what URLs are being presented by those apps, what's going to happen when users click it. So basically test is the suggestion here. Okay, so Azure Active Directory Identity Protection. I'm going really fast here, sorry guys, because we're keeping you a little bit late, but Azure AD Identity Protection basically is a capability that we leverage all of our understanding of threats in the environment that we have identified from people attacking our infrastructure or intelligence that we've got from other big cloud vendors. We leverage behavioral analytics that we derive through analyzing your users' activities with machine learning, and we turn that into a capability to respond to risk at authentication. So we monitor the user's patterns, expose obvious threats, protect against leaked and compromised credentials. So this is intelligence that we get from other vendors. And then we can enforce conditional access based on the risk profile. So
I'll just do a demo.
Jump in, let's do a demo.
So identity protection, again, there's a new Azure portal. And we've got a concept of user risk policy, likelihood the user's already compromised, or a sign-in risk policy, where I want to prevent certain users from signing in based on a condition. And I've got one here that's blocking access for anything that's a medium or a high risk. And what that ultimately allows me to do is if I go to a Tor browser, and attempt to sign in through Azure AD, with identity protection now gating this, we can detect that and I can block access. Obviously being Tor, it's connecting to somewhere obscure. If that policy turned on. I don't think it's saved. So it's off. So let me just save that.
So one of the things when you're deploying identity protection, before you enable any policies, you can start to see the intelligence. What would we have done if we had the policy turned on? So it's a really easy service to start to leverage because you can begin to understand, the impacts, what the risks are. Some of the things you want to think about, you want to make sure that if you're going to use MFA as a control, when we reach a certain risk, we're going to trigger MFA. Are your users registered for MFA? And if they're not, are you going to allow them to register once they hit this risk condition? Because that might not be that sensible, right? So, those are the sorts of things you want to think about planning for.
All right, so the policy's on now. And the good thing is that these policies, they're real time. You don't need to wait any time for them to kick in or replicate or filter down. You can see here I'm now blocked. And I can, as a user, see the more details. And as this user, though, on the same machine, if I went to Internet Explorer or Edge or Chrome, a supported browser coming from a trusted network, I'd be allowed in. But coming through the Tor network, we understand that and obviously block it.
Doesn't go that. I don't think it would be that useful.
What's that?
I don't think that message would be that useful. It doesn't actually tell you what's going on.
No, they're actually trying to rework, but obviously if you're using a Tor browser, I mean, you've probably got a good understanding what's going on.
So we have a kind of competing requirements here. One is that we want to tell the user what's happening, but the other time we don't want to give away what's in our policy, right? Because if it's an attacker, we don't want to be saying, hey, if you do this, you'll be able to get in. So that's the competing requirements. So, sometimes the user might have to call help desk to figure out what's going on.
All right, thanks guys. Now we ran over time.